Hey guys, all right. So this is 4.4 continuation. Strategies for solving max and min problems. Understand. So number one, understand the problem. I know that's kind of obvious, right? Understand the problem. Read, not read. Read the problem. What? You didn't understand the first time? Read it again. Identified what you have and what you are looking for. You know, what's really unique about this chapter is that we are going to end kind of exactly how we begun at the beginning of semester one. And remember, at the beginning of semester one, we did the same exact questions. We were looking for max and min, but we were allowed to use the calculator, and now we have to do everything using derivative. Isn't that amazing how you can solve the same problem, an algebra style and then a calculus style? So we started, and now we're ending in the same sort of like subject, right? Now, if you read it and it's still not clear, draw pictures. I'm a visual learner. I'm always drawing out pictures, as you know by now, okay? Label all parts using the correct variables. That doesn't look like parts. Okay. Number 3, graph the given function. And find the applicable domain or range. And find the applicable domain and range. Now, in an application, lots of time you can't have negative values, so it depends on what kind of question, right? So if it's talking about money, and if you have negative money, that's okay. It means you're losing, right? You're at a loss somehow. But if you're talking about time, you can't have negative time. So it really does depend on the type of question you're trying to ask to find. Number 4, identified the critical points. And endpoints, if we have any endpoints. Number 5, solve the problem. Check your answer or result with a graphing calculator if it's applicable. Okay, if possible. And last one, do you know what the answer means? Can you interpret? Okay, so interpret your solution. I want you to write complete sentences. And make sure it makes sense. Okay. Oftentimes, I'm not going to ask you to round to a certain decimal places. For example, if we're dealing with money, I don't need to ask you how to round, because with money, that's going to be asking you to round to the nearest 2 decimal places, do 2 pennies. Now, if it's dealing with people, human, and whatnot, I'm not going to ask you how to round. You're not going to give me 4.2 of a person now, are you? So make sure you understand the concept and round it accordingly. Okay. Let's go to do example 3. Example 3A. A 216 meter square rectangular pea patch is to enclose by a fence and divided into 2 equal parts by a fence parallel to one of the sides. So it doesn't say which one, as long as parallel to one of the sides. What dimensions of the outer rectangle will require smallest total length of the fence? So right now we're trying to minimize our material. How much fence will be needed? So as you know, we did something very similar to this already in chapter 2 at the first semester, our very, very first unit, okay? So now we're doing the same thing. So good news is when you are doing your final exam, you don't have to worry about what method to use. You can use any method you want. So I read it. I'm going to draw a picture. So this is the length, this is the width. You have a total of 216 meters square, so that's the area. Okay, so the area of any rectangle is length times width. Currently, I know is 216. You are asked to find the smallest length of the fence, right? I'm sorry, the smallest total length of fence, so minimize the material. And how much would you need? So currently, I'm going to solve for one of my variables. Let's solve for L. If I solve for L, and by the way, it doesn't really matter if you solve for L for W. Pick one. Perimeter is just 2L plus 2W. Okay. Now you do not know the perimeter. We're looking for the perimeter. Because I solve for L, I'm going to plug in what L is. Every time I see an L, I will now plug in 216 over W. Plus, I didn't solve for W, so that maintains. And the reason is, now I have my perimeter with one input. In this case, my input is with the W. Okay, next we are going to the rectangular pea patch is enclosed by a fence and divided into 2 equal parts by a fence parallel to one of the sides. Okay, so normally that's what we would leave it, right? We would leave it as 2L plus 2W. We substitute in W. Now we'll go and we can solve for one of them. But it says here is divided into 2 parts, 2 equal parts by a fence parallel to one of the sides. It doesn't matter what side you pick as long as you pick a side. In this case, I'm going to pick parallel to the width. So that means it's an extra measurement. So now I have an extra width. So now I have a total of 3 widths. So as you can see, when you think you're done, you have to go back and reread it again. So now I will FOIL out 2 times 216. That's going to be 432 all over W plus 3W. I'm about to take the derivative, but before that, I'm going to rewrite perimeter as a negative exponent because that will allow me to solve a little bit easier. Okay, so 432 W to the negative 1 plus 3 times W. So P prime of W is negative 432 W to the negative 2 plus 3. We want to find the critical point, so we are going to set this equal to 0. So from here, I could rewrite this again for 32 over W square plus 3. I might want to move the 3 over, so can I just make it equal to negative 3, just like that? And I need more space, so I'm going to go over here. So I will now cross multiply or multiply both sides by W squared. So negative 432 equals negative 3W squared. Divide both sides by a negative 3. So we have W squared equals, let's see, 432, let me bust out my calculator, divide that by negative 3, let's see. 432 divided by 3, so 144, beautiful. So W equals, I should really write plus or minus 12, but we are dealing with length, so I don't need to worry about the negative 12. So I just have a positive 12. So 12 comes out to be the width measurement. Now I just have to plug it in and get my length. I already have a length equal, so I just have to go in here and go, okay, well, 216 divided by 12. So 216 divided by 12, that will give me 18. Okay. What dimensions for the outer rectangle? So I have to write that as a complete sentence. And how much fencing would I need? Well, I'm going to add them all together, and I would write one complete sentence for all of my answers, okay? So as you can see, I have two lengths. So that's going to be 18 plus 18, and then I have a total of 3 W's. So 3 times 12, so total length would be, let me double check, 2 times 18 plus 3 times 12, 72. Okay, so total length 72, I have my length, I have my width. Let's write one complete sentence, okay? The dimensions are 18, I believe the unit of measurement is meters, whoops, meters by 12 meters, and total fencing needed is 72 meters. It's not meters square because it's not an area. It's looking for the outer. And that is example 3A. Let's do the same one, or similar, I wouldn't say, for 3B. So take a minute to copy that down. If you need to, don't forget you can always hit pause, right? All right, as I'm waiting for you guys to finish copying, let's give you a toddler joke. Ready? What kind of flowers has lips? What kind of flowers? What do you think? What type of flowers have lips? Tulips. Ah, you got it. Not as funny, but it's still pretty cute. Example 3B, a farmer with 2,000 meters of fencing. Now you know the fencing, now you know the perimeter. Want to enclose a rectangular plot that borders on a straight highway. Ooh, highway. Okay, straight highway. If the farmer does not fence the side along the highway, what dimensions will enclose the largest area that is, the largest area, question mark. What is the largest area, oops, misspelling, area that can be enclosed? So it's looking for what dimensions in the largest area. So let's draw a picture. So this one is the reverse of the other one. This one, you know the perimeter. Okay, so this is width, this is width, this is length. Your perimeter is 2,000, and I have 3 sides to enclose, so 2 widths and a length. My job is to look for the biggest area and its dimension. So over here, area is obviously length times width. From this perimeter equation over here, I think it's just easiest if I were just to go and solve for L. So to solve for L, I'm now going to move the 2 W's to the other side. Now that I have that, I'm going to now write the area in using only one of the inputs, either L or W. That's really a personal choice. Since I've already solved for L, I would now plug in 2,000 minus 2W for L. So this area is in terms of the width. Let's distribute so we can take the derivative. So that's going to be negative 2W squared plus 2,000W. So A prime of W is negative 4W plus 2,000. Set it equals to 0 because we want to find the critical point. So negative 4W equals negative 2,000. W equals negative 2,000 divided by negative 4 is a positive 500. Whew. When you imagine if that's a negative number, then we really did something wrong. So now I have W, the width is going to be 500. I have to plug it back in to get my length. So length equals 2,000 minus 2 times 500. So this length is going to come out to be 1,000. Now, in addition, before I write my complete sentence, I need to find the largest area. So all I have to do is plug it back in. Area is length times width. So 1,000 times 500. That's going to be 1, 2, how many zeros is that? 1, 2, 3, 4, 5. 5 zeros. So 500. Okay, and then the measurement is square. So let's write a complete sentence with all of those values. The largest area is 500,000 meters square with dimensions 500 meters by 1,000 meters, and box that up. Okay, and as you can see, that's how we do example 3A and B. Largest area or the smallest perimeter, min and max. And that's an egg roll for example 3.